Hello students, in today's class we will discuss about spherical mirrors and some terms related to spherical mirrors. So let's start with our class. Okay, so today we will deal with spherical mirrors. Now spherical mirrors are of two types, concave mirror and convex mirror. Concave mirror has the reflecting surface is curved inwards. Now this is a concave mirror. Here we can see that the reflecting surface, this one is a reflecting surface, is curved inwards. And for convex mirror, the reflecting surface is curved outwards. So this one is the reflecting surface. The rays will come here and strike the mirror. So this one is the reflecting surface, which is curved outwards. Concave mirror is also called a converging mirror, and convex mirror is called a diverging mirror. Now let's see why it is called a converging and why this one is called a diverging mirror. So what happens when the rays of light comes from infinity, they come parallel to the principal axis, and after reflection all the rays meet at a particular point. Here we can see that all the rays are coming after reflection from the mirror, they are meeting at a particular point. That means all the rays are converging to a particular point. That's why this mirror, that is a concave mirror, is called a converging mirror. And this point where all the rays meet is called the focus of the mirror. Let's see for convex mirror. After reflection from infinity, the rays diverge away from the mirror as if they appear to meet at a point, and from this point they are diverging. Hence this mirror is called a diverging mirror. Now this point where the rays appear to meet is called the focus. Now the focus in case of a concave mirror is real, since the rays actually meet at a point, and the focus for a convex mirror is virtual, since the rays appear to meet at a point. Hence we have drawn dotted lines over here. You can see we have drawn dotted lines because this is virtual focus. So any line beyond the mirror should be dotted lines. Okay, so here we will learn some common terms for spherical mirror. Number one is pole. Now, what is pole? The center of the spherical mirror is called the pole. Suppose we have drawn the mirror, which is a part of an imaginary circle. If we imagine a circle and cut out an arc from the circle, so this part of the mirror is a reflecting surface, and the middle portion of the reflecting surface is called the pole. That is the midpoint of the spherical mirror is called the pole. Next, number two, center of curvature. It is denoted by C, and pole is denoted by capital P. The center of the hollow sphere of which the mirror was a part. Now we have imagined a hollow sphere of which we have cut a small amount, a small arc, and this is a mirror. Now this hollow sphere must have a center. That center is called the center of curvature. Next, radius of curvature. It is denoted by capital R. The distance between the pole and the center of curvature is called the radius of curvature. Now this is the center of curvature, which is the imaginary center of the hollow sphere, and the pole, which is the midpoint of the mirror. Now the distance between the center of curvature and the pole, that is this distance, is called the radius of curvature. As we have seen in case of circle, the radius is the distance between the center point and any part of the mirror, any part of the circle. So in this case, the distance between the center of the mirror and the center of the circle is called the radius of curvature. Next, aperture. It is the effective diameter of the spherical mirror. Aperture means this part, and this MN. The small arc which we have considered as our mirror is called the aperture of the mirror. Next, number 5 is principal axis. The line joining the pole and the center of curvature is called the principal axis. Now, if we draw a line and we extrapolate the line, extrapolate means we increase the line. If we draw a line connecting the center of curvature and the pole, and we extend the line in both the sides, then this line is called the principal axis. Next, we come to focus. Focus is denoted by capital F. The point on the principal axis where all the parallel light rays actually meet or appear to meet after reflection is called the focus. Now let's see what is focus in case of concave and convex mirror. We have already seen that when the rays of light comes parallel to the principal axis, in this case this is the principal axis, this line is the principal axis. Now the rays parallel to the principal axis after reflection, the point on the principal axis where they meet is called the focus. In case of concave mirror, we have seen that the focus is real because they actually converge at this point. And in case of a convex mirror, the rays of light after traveling parallel to the principal axis, they appear to meet at a point which is called the focus. So this focus is virtual because this is imaginary focus and the rays appear to meet at a point. Now we will come to the next point, that is the focal length. It is denoted by small f. It is the distance between the pole and the focus. Now again let's see the pictures. Now this is the mirror. This is the midpoint of the mirror, that means the pole of the mirror. Now after reflection all the rays are meeting at this point, so this is obviously the focus. Now focal length is the distance between the focus and the pole. So this distance is called the focal length of the mirror in case of concave mirror. Now let's see in case of convex mirror. So again we consider a convex mirror. So the midpoint of the mirror will be the pole. So this is the pole P of the mirror and the rays appear to meet at a point which is the focus. This is the focus and the distance between the pole and the focus is called the focal length. So this one is the focal length or the small f of the convex mirror. Now let's see the relationship between focal length and radius of curvature. The relationship between focal length and radius of curvature is f is equal to r by 2. That means focus will be half of radius of curvature. So let's see, if we draw a mirror, consider a concave mirror. If this is the pole, this is the center of curvature. So this part will be the radius of curvature, which is the distance between the pole and the center of curvature. And if we assume this as the focus where all the rays meet after reflection, so from this relationship we can see that focus is r by 2. That means focus lies exactly midway between center of curvature and pole. So please go through the chapter. In our next class we will study how to draw the ray diagrams for concave and convex mirror. Thank you.